Thanks for joining us today. This session is connecting Java applications over HTTP to Query API, presented here by Dmitry and Greg, and I'll hand it over to the two of you.
So thanks, Alex, and yes, welcome everyone. In this session, we're hoping to cover a range of the different options you have to connect to Neo4j using the Java ecosystem. And also not just Java interfaces, but also how you can connect with different transports to using the same interfaces. So yeah, my name's Greg, and I work in the networking team at Neo4j, and I'm joined by Dmitry.
Yeah, nice to meet you. I'm Dmitry. I work on the drivers team.
Yeah, so before we dive into the Java stuff, we're going to have a look at the Query API and HTTP connectivity in the database first before we move on. And it's important to note that Neo4j's had a HTTP interface for a long time. So the first interface came out in Neo4j 1.0, way back in 2010, I think that was. And yeah, it's been around for a while, but the Query API is also a HTTP interface, and that has been a bit newer. It was released about a year and a half ago. And it has one distinct advantage over the old HTTP API in that it is available in our cloud service, Aura. Yeah, I'm going to give you a brief overview of what the API looks like. This is basically a state transition diagram for transactions in this API. And the most simple interface or way to execute a query against this interface is this single endpoint. So you have your database and you send a post to this endpoint /db/database name, in this case Neo4j, /query/v2. And in the body of that request, or in the body of that request, you specify your Cypher statement that you wish to execute against the database. And on the server side, we will open up a transaction, execute that Cypher statement, commit the transaction, and then stream the results back to you. So yeah, this is the most simple interface. It gets a bit more complicated with transactions. So to initiate a transaction, you send a request to the /tx endpoint with a Cypher statement. And what you get back in the response to that initial request is a transaction identifier. Here it's this ABCD, which you use then to make subsequent calls to the API, and that basically allows us to marry up the transaction to the one that you're looking for. And then you can execute multiple statements against that transaction until you're ready to either commit it, or by which you do a post to the /commit endpoint, or you decide you want to roll back your transaction, by which then you do a delete to the same endpoint. And that's it. So the entire API consists of these 5 endpoints. Obviously, we haven't got enough time to go deeper into all the different functionality that is available via the API. But yeah, this gives you a flavor. Just 5 endpoints can get you the power of running auto-commit transactions, basically, and also full-on transactions self-managed ones. Yeah, so we're going to do a quick demo of the API. So up here, we have an example HTTP statement that we want to execute. And as you can see, this is where we're running a Neo4j instance locally using Neo4j desktop. This is the HTTP port. And then as you saw from the slide before, this is the /db/database name, query/v2. And yeah, you specify the content type. So the Query API comes in 2 different flavors of JSON. One is a pure JSON format mapping onto JSON types. And the other is a more rich type format that allows you to have the rich types that come with Neo4j, the nodes, the relationships, and dates, and all this kind of stuff. Yeah, so you can choose that here. And then to authenticate with the database, you can use basic authentication. This is standard HTTP interfaces. And also it supports a bearer token. And then in the body of your request, you just write your Cypher statement. So anything in this part here can be replaced with any valid Cypher statement, and it will be executed for you. So if I hit this and run it, we see the response coming back. And we have the field data, which contains the if you like, the columns or the headers of the rows that are coming back. So in this case, it's just one. And then an array that contains the values, an array which represents the values that you get back from your database. And also you get back this thing called bookmark, which won't go into here, but if you're a little bit familiar, that allows you to then take advantage of the causal consistency features in the clustered context. Yep, and yep, that's all. Just briefly, maybe this is the type format for the type format. If I execute this, you'll see a little bit. Yeah, this won't. This gets displayed in a different file, but you see the results from this one. It comes back with the type mapping to that thing. That allows you to do a lot more complex things on the client side when you're passing results. Yeah.
Okay, so now let's talk about connecting Java applications to Query API. Before we get there, you might be asking the question on why you would do that. There can be various factors. One of them could be environmental. Maybe in your production environment, there are reasons for using HTTP. Maybe you can't have a port open for a bolt connection, which our drivers use. There could be other reasons. The point is that sometimes environment introduces some restrictions which make HTTP a preferable transport option. Another option could be potentially tooling, because a lot of people and companies use HTTP tools for various reasons, and that could be also another factor. And the third one, quite simply, is preference, whether it's a personal preference or corporate preference or undisclosed preference. What we do here is we just want to give you the most flexibility. It's not about saying one connection is over another. It's about giving you the most flexibility when you make applications and to be able to connect. So when it comes to practical side, how can you go about actually connecting to Query API? Well, first of all, obviously, there is HTTP client, maybe the one that comes with Java, maybe some third-party library. You can totally use that approach. There are some things that you need to keep in mind if you go for it. First of all, it requires manual handling for endpoints, types that Query API returns, etc. Then also you need to remember that that works best maybe for greenfield applications, something new that you make. If you already have existing application, chances are it's already using a driver, maybe it's using Spring Data Neo4j, you would have to remove that because obviously of this change. And then obviously you would look yourself into a specific API at this point. So we were wondering, what if you could actually use drivers? What would be the benefits of doing so? And one of those is obviously you would keep using the well-known client API for both engineers and tooling. If you have existing application, ideally it just switches over. You don't need to rewrite it. You don't need to change the code basically, and you remain flexible in terms of what connection you pick. So there is no lock-in on a specific server API, so to say. So talking of drivers, actually at Neo4j we have 6 official drivers for 5 languages. So we have Python driver, we have JavaScript driver, we have 2 Java drivers. There is the Neo4j Java driver that follows the ideas of the official drivers that we have for other languages, and there is also a JDBC compliant driver to give you the most flexibility. Then we have .NET driver and also a Go driver. Let's also not forget about our beautiful community drivers. You can find out more about them by following the link at the top of this slide. Now let's have a closer look at how Java driver is used. So typically you add the Java driver as a dependency to your project. In this example, I'm just giving you a Maven example. Then at the bottom, you have a small code snippet that basically shows how it's typically used. Like the simplest way possible is just an auth token. You then create a driver with the URL and the token. Then we execute the query. And in this case, we just print out the records. So like I mentioned, the official drivers all use Bolt protocol for communication with the database. It's an application protocol. There are some specific traits we want to focus on here, which is the fact that it's a binary protocol, it is stateful, and it is message oriented. So typically driver opens a connection to the database and sends messages back and forth to communicate with the Neo4j server. So obviously it has a number of messages to do this job. There are different types of them, like run message, which actually sends the query to the database. There are messages to begin transaction, to commit it, to roll it back, etc. You get the idea. Going slightly more into details, the drivers actually use something called Bolt connection library to carry out the lowest level communication on network. So Bolt connection library basically takes care of connecting to the Neo4j and exchanging messages with it. To give you an example how it actually works in practice, on the left you have driver, which is split to higher level logic and Bolt connection, and on the right you have the actual Neo4j server. During the query execution, the driver submits run and pull messages to Bolt connection. Bolt connection then sends them over the network to Neo4j. Neo4j replies with run summary, which is a response to run message. That can be handed over back to the higher level logic of the driver. Eventually, records start arriving in streaming fashion, so they are streamed back to the driver, and pull summary arrives as well, which is also given back to the driver. So when we looked at this, we naturally asked ourselves a question: what if we created a Bolt connection that implemented this logic by actually translating the messages into respective query API calls and talking to query API, and then giving the results back to the driver? Let's just picture how it would look like. So same setup. On the right, you have query API. Driver still gives it run message and pull message, but Bolt connection actually sends a post request to query API. Query API replies actually with fields and all the records. That is a small difference to how Bolt works. Run summary can be served straight away. Then all the records should be saved into the memory. So one of the things with this implementation is if you actually get a lot of records, this implementation means that you need a bit more memory essentially to handle that. The records can be then streamed back to the driver. Also, if driver comes back for more records, they will be served from the memory of this Bolt connection essentially. When it comes to clustering transactions, there is also additional responsibility this connection has. Essentially, if you have a cluster of query API endpoints and you have a load balancer, when an application sends a post request and load balancer sends it to a particular server, the server will actually include an HTTP header called Neo4j cluster affinity with a value that represents the member of that cluster. So whenever this connection needs to communicate regarding this transaction again, it has a responsibility to include this header so that the load balancer can send it to the correct destination. This is all handled basically by this new implementation. And at this point, we are going to show you the new module that we made for the Java driver, basically. I just want to point out that this is a preview feature. Preview feature essentially is something that we aim to make a GA. It's not experimental, it's not temporary, it's not unstable. We intend to release it fully, but with preview features, we can iterate on them faster. They don't necessarily follow the same deprecation cycle, and we really need your feedback. So we would really appreciate if you give us feedback. You can do this by going to this GitHub discussion on Java driver at the top of the slide and tell us what you think about it. Right, so when it comes to query API module, so it's an optional module that comes with the driver. You basically need to add it to the runtime. Once you do that, the driver starts understanding an HTTP URI scheme. Also remember to use the correct port. So you need to use the HTTP port now. That's basically that simple. You just need this additional module on the runtime scope. So you might notice that I didn't actually specify the version of that module, and that's because we also introduced a Java driver bill of materials. So we suggest you use that in Maven or Gradle. You can basically add it to the dependency management section, and it will make sure that whatever modules you add for the driver, they are always compatible with that version of the driver. So it just simplifies version management. There are some small limitations given this preview feature. For instance, we only support 3 auth token types. We don't currently support Kerberos and custom tokens, but we believe those 3 pretty much cover most of the use cases. The other thing is home database resolution is not currently supported. So typically when you use the driver, like on this example, when you send a query under a specific auth token, what happens is that Neo4j resolves the home database for that user and then executes the query for that database. In this new implementation, you need to specify the database name directly. This code shows you an example how to do that. You basically create a query config with a specific database name, and then you can reuse this config for multiple query executions. That obviously needs a code change. If you don't want to do that, there is an optional client-side query string parameter that basically allows you to specify the name for the database, which will be used as a default if you don't specify it via the API. So in a way, it's the simplest way to solve this problem. Now, let's go quickly to the Java driver demo. So in the demo setup, just to give you an idea, in the middle, I have a web app that is built with Spring Boot and Micrometer. We also include the Java driver and the new Java driver additional module to integrate it with Micrometer observability. You will all see it in a moment. There is obviously Neo4j. On the right, there is observability stack. So Prometheus collecting metrics, Grafana Tempo accepting traces, Grafana itself to present all of that. And on the left, we basically have a basic HTTP client. So now going back to IntelliJ. Right, so this is basically the application we have. Now, in POM file, I'm using the latest release candidate of Spring Boot parent. Fairly soon there will be a major version, so we suggest you use that. It imports the BOM file from the Java driver, so you don't need to worry about it. I'm just making sure I'm using the latest Java driver available. And like I mentioned, I include the observability module, which will help us a lot to understand how things work at the moment. There is also application properties file. As you can see, I'm connecting to Bolt at the moment. So what we have also, we have a controller that gives you the list of movies by executing the query. It's also using another new feature in the Java driver that lets you map the movies directly to Java records, so you don't have to do it manually. That's another interesting part about it. So let's just quickly run the application now. So remember, we are connecting over Bolt at the moment, but let me just show you how it works. So we send the query, we get these movies back with titles, directors, actors, etc. So now if I just exit the slides quickly, go to the Grafana, and just sometimes there is a small latency in traces arriving, basically. So this is the trace for get movies. If I open that, we can see that basically it was essentially a Bolt exchange. So if I go to span attributes, you can see run and pull messages, Bolt protocol, specific version, etc. Now, what do you need to do to actually switch over to HTTP with all of this? So first of all, like I mentioned, you do need to have this additional dependency, which I already have. It's in runtime scope. That's all that is necessary. And then essentially all we do is we just flip the URL to HTTP URL with HTTP port. So now I can go ahead and restart the application. I can then send a request. You can see the result is coming back as previously. So now I need to close this. Give it a second for the trace to become available. Yep. Get movies. Let's make it wider. And now you can actually see that this was indeed a post request with a lot of additional information, but we can see it was going to localhost, to HTTP port. So wire tracing, you can pretty much see that this is no longer an bolt exchange, it's now HTTP exchange. Yeah, so with that, I'm handing over back to Greg to do the Spring Data Neo4j demo.
Yeah, so Dmitry just showed you the pure Java version, but obviously the Java ecosystem has many different kind of options available, and one of that we're familiar to many Java developers is the Spring system in general and Spring Data in specifically. So, and this is the setup we have for this next demo. And by the way, Spring Data is kind of this nice abstraction layer above that sits above your database that allows you to basically decide the data store that you want to use later on, and also map onto types similar to how we have in the Java driver with the record example. And at Neo4j, we have a specific graph database or Neo4j implementation of this called Spring Data Neo4j, which allows you to do this same thing you can do with standard Spring Data, but with Neo4j stuff, basically. So yeah, we're going back to our code again, and we have, as I said, the same setup as we had before in this repository here. Basically, everything is the same. So it's a Spring Boot program, same controller, REST controller, and basically same everything, except we're now storing and retrieving our data via Spring Data, Neo4j. And you can see here we have this class called, or interface called Neo4j repository, which allows you to define your query layer on top of your database. And this is how we will search for the movies that we'll return in our movie controller. What you get back here is movie entities or Java objects representing the data that's within your database. And if you're familiar with the Spring Data stuff, it's essentially the same thing as before, but we have some specific graphy kind of things that come back, right? So we want to tag our entities as nodes, and within nodes we have relationships, as, for example, but you can specify all the different properties that belong to that entity. And what will happen in the background is the driver will go away and do the queries for you and map these things onto these objects. Yeah, so as I said before, it's exactly the same example. So we stop the previous one and we start the SDN version. Again, first up, we're using a bolt, which is on this port of the database. And if we send our GET request this time, we see all the lovely data coming back in the same way as before. If we hop over to Grafana, close this down, and we switch over to look at our SDN example, we have to, again, give it a little bit of a refresh so it can pick up the latest data. Yeah, and we see down here we got a trace for the first request we did, and as you can see with the plain Java example, we've got a span here that's basically exchanging bolt, exactly the same as we had with the previous one. So again, we go back into here, we swap out our bolt URI for a Neo4j one. And it's key to highlight here, this is exactly the same setting, nothing else changes within the code base. We restart it, and we do the same request again. We see all the data coming back as before. And if we go back to Grafana, close this down, do a refresh, give it a little bit of time.
Yeah. One more.
One more. Yeah. And yeah, we see our span come in for this one. And again, now we see something that looks a little bit more like HTTP rather than bolt. Yeah, so this is the Spring example. We have one more, and that's via JDBC. And again, lots of Java developers will be familiar with the JDBC library or interfaces. They again provide a nice abstraction layer over your database, so you can delay the decision about which database you're going to use later on, and it's a uniform one. JDBC isn't specifically linked to relational databases, so we can swap SQL statements for Cypher ones. We'll see that in a second. And just to give an overview of the demo setup, again, exactly the same as before, but this time we have our JDBC, the thing that's driving the results or the communication between the database. So we go back here. Let's close all these down and open up our JDBC example. And I forgot to show you sorry, we'll just jump back to SDN quickly, that we have the only things that change on the POM side for the Spring example is that you bring in the Spring data Neo4j starter, and that will allow you to bring all the Spring data dependencies. And again, you will need the Bolt, the Query API specific implementation of the connection there for the driver. Yeah, forgot to mention that. But going back to JDBC, the only thing you need to add here is this JDBC library, and within that already has the HTTP connectivity layer there, so there's no extra things you need to bring in. Again, if we look at the rest of the code here, we've got, again, everything very familiar, the same controller. Oh, sorry, I'm looking at SDN. That's why everything looks wrong. And yeah, so here, very simply, essentially the JDBC driver, and we execute our Cypher statement and return our results. This one is a little bit more simple. But we run this one. Oh yeah, and again, key to highlight that this one is communicating with the data store on the Bolt port. So we started that up, and we go back to our request and execute the movies. See all the lovely data coming back again. Wrong way. And if we go to Grafana, give this a refresh, and go to our JDBC demo this time and have a look at the trace for this example, we will see a little bit less information on the traces. But if we click here and we look at the span attributes, we see that it's communicating to Neo4j over the Bolt port. Yeah, going back to the example again. So if we pause, stop this, and go back to our Spring application config file and do the same thing as the other two examples, comment out that, and swap over to Spring data source. JDBC URL looks a bit different, but it's fundamentally saying the same thing. We're talking now to Neo4j using HTTP. And we restart this one and send a request in. You see everything comes back. Again, wrong way. We go to Grafana. Give this a refresh. Yeah, right. Give it a little bit of time, and there it is. Here we go. Let's see. Hopefully, we will see HTTP here this time. Yeah, and we see. Oh, yeah. Let's make this bigger. Yeah, we see this time now we're talking to Neo4j on the HTTP port. And so, hope you can see there's lots of options and powerful options for you to choose from, both on which API you use on the surface, and the transport layer gives you like full flexibility to make decisions that are best suited for yourselves. And yeah, we hope you try these out and give us your feedback. So yeah, here we have a bunch of links to dive deeper into all the different things that we've covered in this session. The top one is for giving us feedback on the specifically for the Query API implementation of the driver interface, and then yeah, a whole bunch of links for Query API documentation and other bits and pieces. And yeah, thank you very much for listening.
Thank you.
Yeah.
Thank you.